Welcome back to the stream, everyone checking in early or tuning in the archives. It's been a few days since the last one due to all sorts of real life happening, but now I'm back with some 3D prints, did some CAD off stream, and so part of this stream we're just going to be looking at the results of that and some parts that I just finished printing. But then later we'll get back into the progress on trying to both understand the Gimbal protocol and try to kind of unbreak the one that I messed up some of the parameters in. So that's what I plan to get into this time. So welcome back. I've got this part, which we'll take a look at soon, but let's spend a little time with the cat first. Gotta get enough cat here. In fact, I forgot to make myself a cup of tea before the stream, so I'm just going to give everyone a little bit of cat while I make some tea. I'll be right back. I lied, the hot water machine's empty, and Tuco stole my seat. Well, the hot water machine will play us a little song, and then I'll get a cup of tea. Hey, cat. So, yeah, you might have noticed this weird piece on the desk. So this thing just finished 3D printing this morning. This is still like a beta part. This might have terrible problems that require massive rework, but this is my first attempt at the kind of main load-bearing core of the Winch robot for this cat robot project. So we'll take a look at how that fits in with everything else on the computer in just a sec. Oh, little cat, you really like to steal my chair. Am I gonna have to get another chair? Cat, you're not making this easy today. How's that? I think that's gonna work. Okay. I think we're gonna be good to go for this next part. So, let's use this one. Behind the scenes in the topic channel. Alright, so this is the piece we just printed. Or no, sorry, I lied again. This is the piece I just started printing, which is going to still be very much a work in progress. Seems alright so far. So we'll get to this in a sec. This is the massive CAD model of this entire thing so far. If I turn on these. This is a rough idea of what this Winch robot is going to look like. Maybe I'll turn off the internal parts for just a sec so you can get a better view of what the whole thing looks like on the outside. Anyway, there's a bunch of junk on top of that, but basically it's going to be something about this shape that attaches to the wall. There's going to be another piece back here that I haven't designed that acts as a mounting bracket. And mostly, well, it's easy to get disoriented when you have hidden edges on. You can like forget which edge is in the front. But yeah, this screw back here will go into a nut in a mounting bracket. So the idea of that is it'll allow this whole thing to pivot side to side, allowing me to point it directly at the pulley on the ceiling. I might also need more degrees of freedom, because really for this to work optimally, you'll want this lined up so it's pointed right at the ceiling pulley. And depending on where I can mount these, I might not have a whole lot of flexibility to put these directly under the pulley, so maybe being able to angle it in 2 degrees of freedom would be helpful. But the overall design here, I tried several things, and what ended up working out the best, at least as far as I can tell, is to design this so that the shell of this whole thing is in 2 separate pieces that are mostly not really load-bearing. This shell on this side has one load-bearing job, which is to hold the center of the spool, which is its job is shared with the motor. So I'm a little worried about that. So this piece is reinforced such that it can distribute the force from this bolt back to these 2 bolts. So that's why this part has some reinforcement inside, and it's using M6 bolts. But the other shell its job is to actually also to hold the electronics. I was hoping not to mount the electronics to one shell, because then when you take it apart you have like wires splaying everywhere. But I didn't really see a good way not to do that, at least not that wouldn't use tons of extra plastic and require a bunch of extra print time. These pieces are pretty big as it is, so I was trying to do this with an eye toward them being like 1-day prints and not like 4-day prints, So to that end, each of these top and bottom pieces are actually pretty simple. Like if we just take a look at these layers by themselves. So this is the mechanical shell, which is the one that's printing right now. This is where the cord actually enters and exits. And then this is the mount for one side of the spool. And not a whole lot of room to reinforce these, but I did what I could. So this is one of the pieces I'm least confident about in the design. There's the other shell, which I'm still working on. It's got some of the mechanical supports here, but I haven't actually made the mounts for the electronics yet. There are some cutouts that go here for the electronics. If I just turn everything on, there's a lot going on here. If I actually turn both of the shells back off, you can just get a sense for kind of how I ended up organizing the parts. So the biggest things clearly are the motor and the spool of extra cord. So the motor is big and heavy. I want its center of gravity to be pretty close to the wall where this is mounted. And it's also just big, so I rotated it so that I wouldn't make the envelope of this any larger than it had to. And then that left just enough room up here for the circuit board. This is the microcontroller eval kit with its Ethernet. And so these being on an external edge actually set a good bit of this shape for this part of the design. So you can see that's where this angle came from. This is directly related to how the motor's positioned. And then because these pieces are so big, I wanted to just focus on them having a nice shell and relatively uniform thickness. So I designed them pretty much hollow. And then if you look at just the internal parts here and what these pieces need to be strong relative to each other, I tried to keep that to kind of a minimum. So for example, this load cell is actually holding all of the weight of, well, 1/4 of the robot. So this winch's entire load is on this pulley, on this load cell. And then the load cell is acting as a lever so that all of its load here is acting to kind of torque this component here. So I reinforced this with a bolt. This bolt just goes through the plastic core as a reinforcement right here, and then these actually hold the load cell on. So that's another kind of weird mechanical feature that I kind of designed based on a collection of hunches, and I'm hoping it works, but it's certainly an opportunity for failure. So that's kind of the strategy I took, is to use bolts and plastic to kind of spread out the load and use the bolts to reinforce the plastic and use the plastic to create the arbitrary shapes. Then you can see this is the long M8 bolt. I think this is M8 by 150 millimeters. This is what actually kind of acts as a reinforcement for all of these pieces with each other and then holds the whole thing onto the wall. So if I turn on the core piece we just printed, its job is to just facilitate all of those interactions between the bolts, basically. So the M8 bolt goes through there, holds this whole thing together. If I turn off the internal parts, you can see more easily that, for example, those pulleys are supported by M6 bolts held into kind of little bumps on this core that kind of hold it as well as it can without getting in the way. Big hollow area for the spool motor mount. So that's basically what we're dealing with here. If I turn on the mechanical shell, you can see it attaches mostly with these two M6 bolts. And then similarly, the electronics shell on the other side attaches with 4 M3 bolts right there. And these are mostly just a combination of where I thought it needed to be strong and where I had the space to spare. And this is missing some parts on here still, but yeah, mechanical design's getting closer. So let's take a look at the actual piece and see how close it is to working, maybe. Also, on a slightly meta note, I had been having a lot of trouble with that flexible button panel that I built for the stream previously. It didn't really succeed at its job of being flexible enough to go around the poles here, and I was having some just problems with its style of analog inputs to read the buttons now that I had more USB extension cables and kind of a variable 5-volt supply. So I was thinking, well, build versus buy. I could have easily built something, but it also seemed just worthwhile to try to buy something that did exactly what I needed. So this is the thing. It's an X keys. I think it's called the 16 key stick or something like that. But this actually seems to work pretty well for what I need it to do. So here's the real piece we have. Kind of formidable. Had a little bit of trouble printing this. The first time I had just not let my very feeble printer bed warmer get up to temperature, and I had some warping that caused it to fail. This print mostly succeeded. There's one error I'm slightly annoyed with. You might be able to see that everything above this point right here is offset that way, maybe 0.5 millimeter, which might be a problem. It still seems like it's strong enough, but that will upset the tolerances a little bit in places. And I think what happened there is the print head might have just hit the surface at one point and then caused the x-axis to skip by a few steps. Might also be that I need to relubricate the x-axis, but we'll see how far we can get despite that print error. All right. So some of these pieces I've already cheated and tried a little bit. I cleaned out some of the printer support material. This is an M6 by 40, I think, yeah. So this is, for example, the M6 that's going in just for reinforcement purposes. Just testing out the tolerances with this. This is maybe less of a clearance hole than I was hoping it would be, but it goes in all right. Microhex says, if I had a 3D printer, it would never stop running, and I would have a constant stream of filament spools coming in. Yeah, it's not too far off from the state here. I mean, I have 2 3D printers here, and it's not like I'm running both of them all the time, but I usually have something I'm doing. I have time periods where I'll run both of them when I need a bunch of parts for a big project. Running a 3D printer all the time, though, you also end up having to deal with maintenance costs. So I think the main consumables on my Type A printer are, well, every so often the nozzle needs replacing or cleaning. I just replaced the nozzle, though, and it's a tungsten carbide nozzle, so it should last quite a while. I think the next thing that's going to go on that printer is probably going to be the flex cable for the head, or maybe one of the belts. So this is actually threading a little bit, so I'm going to need to put the nut in first. Microhex also says, also, can you imagine how much this would cost to mill? Yeah, this would be an expensive milling project if I was... I mean, that's the thing, like, I don't really need the whole thing to be made out of metal, but if I was using metal, I would design this differently. You know, I would make the whole thing much smaller and easier to mill. A lot of the complexity of this is because I'm using all of these different features that have to be at different heights for the cord that's running through this to all end up running on the same plane. So that part ended up being kind of complicated. And if I was milling this, probably would have made a lot of different design decisions. There's another thing I'm a little worried about here. I don't think I added quite enough extra clearance on this cutout for the motor. I did add a bit of clearance, but I think it might have been on the order of like 1/4 millimeter or something, which is kind of my go-to clearance for these 3D printed parts have to mesh really well, even despite the printer messing up slightly. But I think this motor might have slightly more variation, but I don't know. I think I got it to fit before it was just a little snug and might not have been fitting amazingly flat. So the motor fits in there. Part of the goal of this hollow here, you know, I could have easily set the motor back another millimeter and not had to hollow that out, which might be a good design decision because then I'll get a flatter place to mount the motor. My thought with this was that I wanted this little rim around the motor to help take some of the torque load so it wasn't all just on these 3 screws, to kind of spread the force out to a larger plastic piece. I'm also noticing I have to slide a nut in there before I mount the motor, so let me go ahead and do that. So nut goes in there, motor, and so this fits tightly around the gearbox and then secures in with some M3 screws. Oh yeah, just catching up on chat a little bit. So Vince is asking if it prints internal threads. Yeah, you can print threaded stuff if the threads are really huge, but usually you avoid that. You can tap plastic. In fact, if you haven't seen it, Fran from FranLab just released an awesome video on a kit that she's been working on of a replica of the Sputnik model, and it's really cool. You should check out this video. But she was also making a 3D printed case for that, and I had good luck just tapping the center of a 3D printed, cylinder basically, and then threading a large. It looked like it might have been on the order of like 1/4 inch or like M4 fastener or something, but I don't know exactly what it was. I'm going to use screws with a larger head here. I was about to put in some tiny screws, but I think I have a better choice. Are we going to be servo AF today? Oh, thanks for the link. Yeah, and then there are a lot of other ways of doing it besides threading. I've been experimenting with thermoset brass inserts lately. So the easiest way I've seen to put them in is to just stick them on the end of a cruddy soldering iron tip that you don't want, and then use that to heat up the insert and press them into the plastic. And so it's basically like a little heat set nut that you can put anywhere you want. The actual grip that I've had between PLA and that nut hasn't been amazing, but there might just be a technique that I'm not getting right. Now I'm having trouble getting this screw out. It's also, I'll use captive nuts plenty, just like having a slot that you can slide a nut into. But lots of ways to do fasteners. I like browsing around Thingiverse or other people's 3D printing YouTube channels to get ideas for fastening because there's just so many interesting approaches. A few of these M3s. Let the servo AF catch up. I think we want the lime green wrench for this one. I really appreciate these fancy wrenches. They are overpriced, but the color coding, I admit, is really nice. I imagine just putting colored heat shrink on some other set of wrenches might have been a good decision. Because it's much easier, at least for me, to remember which wrench goes with which screws with a little bit of extra sensory cue. Ooh. I think that means I can have tea. Oh, Microhex says, speaking of 3D printing, with a link to the RepRap Helios. Is that the one that's like an arm robot? If that's the one I'm thinking of, that was a really weird 3D printer. I haven't actually seen it in action yet, but it seemed like an interesting design. I think they used really like large wheels at each joint and then made it belt driven. Yeah, super strange. So I'm just keeping an eye on, actually this might be a little better than I thought. Just looking at how flat this is sitting, I think that this needs more clearance. I think the barrel of the motor here might actually be causing the whole thing to tilt that way a little bit, which could be a problem. Could give me excessive wobble when the spindle is turning. Tightening that might help. I don't know. That still seems like it's not sitting quite flat. But it is in there pretty well. Like, it might not be a planar joint, but it sure is sturdy, I think. So far, I shouldn't jinx it. I also don't want to over tighten these, but I want to make sure they're all tight. This one is not. So I could put the spool on right now, but that would get in the way of most immediately the load cell, so I think it makes sense to put that on. I already have the rest of this assembled. This is something from earlier. So this is a load cell, the same kind you'd find in like a small like postal scale or like a like a kitchen scale. And this is a bracket from earlier that grabs onto this end, has screws holding it on. This again is another piece that has to hold the entire weight, but as you can see, it's not really that much. This is also a bit of a strange mechanical design. It's actually supported on this side really sturdy by this nut, but on this side it's actually kind of a collar that grabs around the screw. I've already noticed kind of some weird side effects of this design. So right now this turns quite nicely and smoothly, but in fact if I push this and cause this front to flex just a little bit against that, then it starts to rub. And that's just because this is not really attached firmly, it's just a collar around the screw. So then if I separate these a little, there are a bunch of solutions to this if it becomes a serious problem. I think the most elegant solution might be to cut a little material away from the face of this idler pulley to make room for that to grab the bolt head more securely. But I could also get rid of that little bump there and replace it with, like I could basically make this whole thing two pieces if I wanted. Like that would be another solution. Oh, interesting. Ken Keeter suggests that Simplify 3D might allow you to add extra infill around specific features, like maybe around where fasteners are compressing. Yeah, that sounds interesting. I had a brief experience with Simplify 3D, but I think I didn't really find it especially useful at the time because the built-in profiles on Cura for my printer are actually pretty good, and I felt like it was a big step backwards to go to Simplify 3D and then have to like recreate all the profiles from scratch. Which would be nice, like if I was starting from there, it does seem like it would be more powerful, but at the time it was just not really worth the huge amount of extra work. That's the shot I wanted. Thanks for focusing, camera. Maybe today is a bad day for Servo AF. That's better. Oh, nice. Ken Keeter says that they've ported most of the profiles. That's cool. I might have to give it another shot then. All right, so for this fits in here, and there is some room in the back here for the wiring. This is such another really weird shape. The idea is the load cell sits in there, there's room for the wiring, there's room for this to... Basically, I'm following the manufacturer's data sheets on keep out regions for where that silicone stuff might be. And so based on that, I think I've got this mounting so that it won't actually be pressing on any of the delicate parts of the load cell. And there's a little hole there that I can fish the wires through so they can get to the other side. So let's try that out. And which screws am I using for this? The servo AF switch is right next to the lens stabilizer on-off switch, which is not what I wanted. Really would be nice to have a way of automatically moving this cat camera, wouldn't it? I think M5 by 20s are what I want. It was either 20 or 25. Oh, looks like I designed this for 25. I could go check the CAD model, but it's easier just to look at the piece and see what is obvious. Because that is obviously designed for an M25. Ken is asking whether I've thought about opening up my camera to add big controls for some of the features that I use. Like the DSLR here. I guess I hadn't really considered it. I mean, the camera has been pretty... Like, I haven't really found the camera's UI to be that limiting. The thing that I most dislike about this camera is it not having clean HDMI output. But I figure I'll just live with it for a while and then eventually upgrade to 4K. Because I figure at some point I'll want to do 4K video. It's just right now I've got a lot of 1080p equipment here. And partly the reason I can do that is because the 1080p equipment is getting pretty affordable, whereas the 4K stuff is still kind of expensive. But even just like one 4K camera and then 4K editing, I'm assuming would make a big difference for some things. Okay, let's get these wires fished. Oh yeah, the camera. So it's an EOS Rebel T5i, which I think also goes by another name that I'm spacing out on, but T5i is what this one was marketed under. So these are going to go through pretty much all the electronics go on the other side. And this was the one piece that didn't already have its wires coming out on the other side. You know, we've got the optical encoder, we've got the motor, we've got like power and Ethernet. And so this was the one thing that needed a feed through for its wires. And this will go directly into an amplifier that'll be stuck onto the other side of this piece. I added mounting holes for the load cell amplifier in the CAD model, but that was right after I started this one printing. And I didn't really care enough to go restart the print, because I figured we'd find other problems too. And if that was the only problem, I really wouldn't mind just gluing the load cell amplifier on, but I figured we'd probably find other problems. Or I could use a drill press to make holes, you know. I still have that capability. Oh, Peter is asking where I got the Keysight scope. The Keysight scope was actually a contribution from an extremely generous viewer, so I don't remember where it was actually purchased. I think it might have been directly from Agilent or via their eBay store or something along those lines. I'm starting to feel this catch the screw. These holes maybe could have been slightly larger for clearance because I'm basically threading them. And that's going to mean that I have to hold these together or else they'll thread such that there's a gap in between, but... Oh, good question. Dale is asking what the print time was for the main body piece here. I would have to check. My camera for time lapses was actually down during this print. I think I've got it fixed now, but so I don't know what the actual print time was. I think Kira was estimating something like 17 hours, and that sounds about right. Maybe it was more like 15 hours, but yeah, something in the small 2-digit numbers of hours. I think this is working. Cool. Don't want to over tighten these, but I think this is working out. This is one of the more sketchy mechanical parts in here, since this needs to carry pretty much the entire load. So sweet. That's looking all right so far. Comes through there. I kind of want to put the optical encoder on next. Although really we should check out the wheel, since we can put that on now and see how bad the wheel is. Because I'm a little worried about the angle the motor is sitting at. I don't know if we're going to see good performance out of this, but let's give it a shot. Can I also try to prop this up so it's a little more horizontal? Good luck with that. Yeah. All right. So now I just need one of these spools, and this takes an M3 nut, and I think this is another M3x8 for a set screw. You know, I'm going to check the CAD model, because if it isn't an M3x8, getting that screw out is going to be annoying. So this is going to be this screw. I just want to measure the length of this. I've gotten a little bit more used to the selections in this program. I feel like I've gotten most of my CAD muscle memory right now invested in a tool called Rhinoceros, which I really like, but it's very different from Fusion 360. And one of the things that took me the longest to get used to is how this selects based on, like, everything is based on solid objects in Fusion 360, which is kind of a weird paradigm when I'm used to tools that are based on edges. So I'm used to selecting things based on edge. So it's like I get close to where the edge is drawing of the piece that I want. But it seems to want to just project a ray forward through wherever my mouse is and give me a list of everything that hits, which is really different. So Dale is asking if there are any cheap off-the-shelf pulleys I could use, since the tolerances on powertrain friction surfaces might be tight. I don't think I have any powertrain friction surfaces. Those are all on bearings. So the reason my pulley was catching earlier was not due to something that's not something that's supposed to be a friction surface. That's something that is just a design issue where I don't know how severe it is, but I think I know how to fix it. Oh, did I misaddress somebody? Ken says I'm Ken, which is probably means I misspoke earlier. Sorry. What did I just measure here? I think I cleared my measurement window without actually looking at what it said. Oh, it's written in black on dark red text as 8 millimeters. So I think we need an M3x8 screw there. Oh, I think maybe what happened earlier is I didn't notice Ken's icon because it's so close to the background color on the screen I was looking at. Sorry about that. Do I really not have M3 nuts on my desk right now? I'm gonna have to get up and get M3 nuts. I'll be right back. So many kinds of M3 nuts. So this one just slides in there. Camera's gonna stop recording any minute now. There we go. I feel like there's so much multitasking involved in doing these streams and recordings that I always notice stuff I missed, like when I'm going back and watching the recordings for editing or like just spot checking the online archives. Especially stuff in chat, like I'll notice so much stuff that people are trying to get my attention over. Sometimes it works, but there's many distractions. I'm trying to get better at that though. This is a little, I think the opening here needs a little clearing out. There was a brim around this when it printed. I usually print with a brim to help with warping, but I don't think I cleared all of it off this time. Oh, I guess there's a problem in general with the icon. There we go, now it's going in. If it would ever focus, jeez. I think I'm gonna regret turning off the servo AF at this point. All right, so I think that's in there. Back to the old friend, lime green wrench. Oh, sorry, didn't notice the comment on the YouTube chat either. Ravi is asking, what are you doing? Well, right now I'm putting together some 3D printed pieces for a robot that's going to follow my cat around with a camera. That's basically it. Of course it gets complicated. I'll try to explain the details, but that's the high-level view. This is a little bit not going in. Oh no, there it is. So I'm just making sure that this is going in the nut, but I'm gonna back it off so that that shaft way is totally clear. Oh, cool. Thanks for the link to the other stream, Piotr. Yeah, so I've been experimenting with doing broadcasts on multiple services simultaneously since it's nice not to rely on just YouTube. I was doing some stuff on Twitch before. I've still got a stream on Twitch right now that's just the 24/7 cat cam, which will eventually be robotic, but currently isn't. So this seems to go pretty well so far. But then I've also got a copy of this stream at beam.pro/scanlime, which is kind of a new service that I've just started experimenting with, but it seems to be pretty nice, you know, low latency and not trying to monetize everything as heavily as everybody else. So I think there's a little bit of leeway to adjust this up and down, because this doesn't have to be pressed right up against there. I think it's actually supposed to ride a few millimeters up above there. So this might need adjustment in the future, but I'm gonna just set it somewhere right now and tighten the set screw. Peter says, how do you paste Twitch without autoplaying the link? The only way I know of is to not include the HTTPS or whatever. If you just say twitch.tv/whatever, then it'll make the link clickable, but it won't autoplay it, I think. Yeah, Gitter has a really annoying autoplay feature. That seems tight. There is the robot coming together. Starting to look like the CAD model. This actually looks all right. I kind of want to connect the motor to a power supply and see how much wobble there is. So, get some leads for this. Maybe actually get a shot of the power supply. I hardly ever bother getting the power supply in frame because it's way over there, but I think I actually don't have a bunch of stuff in the way this time. Well, maybe that's why I don't get the power supply in frame. Daystar. I do enjoy doing more of these streams earlier in the day. I think for a while I was doing them mostly in the evenings. It's nice to have a mix of time zones for everybody's benefit, I think. So just to see what the limit is set at, a couple amps. Let's start at a lower voltage. There goes nothing. Whee! I don't think it's scraping. There's a little bit of like maybe weird vibration noise, but it's not like scraping anywhere. Let me try turning up the voltage. This is a 24-volt motor. This is it running at 15 volts. Yeah. I think just the eccentricity of the shaft not being perfectly aligned is worse than the motor not being perfectly flat against the plate at this point. But both of those seem to be pretty much within my design tolerances for wobble. Yeah, there's a question about the noise. I'm not sure about that either. I think that might be some vibration in the gears that's being amplified by this big plastic plate, but it's kind of hard to tell. This definitely needs more room for the motor body, though. Like, this is very, very not flat. So, like, that is almost touching, and the problem is this just doesn't have enough room to hang out in there without touching. The other piece I'm printing currently is the piece that supports this bearing. So I really want to try that out for mechanical reasons. Like I want to try putting that together. And my fear is that once I put that on, the entire enclosure is going to kind of creak as this turns. And if that's the case, I'm going to need to find a plan B for that whole thing. Peter's asking, could the noise be ripple in the power supply? Yeah, I don't think the noise is either the power supply or rubbing. I think that's just gearbox noises being amplified by this thing. Eagerly waiting for short out, thanks. I mean, I could try tripping the current limit, but That's doing all right. That's drawing about 2 amps. Oh, that short out. The cable's moving around. Yeah, well, maybe. I guess that could happen. It'd be fine though. The 3D print, the power supply is current limited. So this also doesn't seem to be a problem. Anyway, so we should have a list of problems. Like, obviously, the motor needs more room. This needs the mount for the load cell amplifier. It'd be nice not to have that printing offset that happened. But there are some things I still want to test with this piece before I even think about reprinting it. Which is, I want to mount at least a couple of these pulleys and see how evenly this thing winds. Because that I'm actually pretty concerned about. I want to watch this thing wind and unwind because that could be a major issue with the design that I need to know about sooner rather than later. Peter's asking if I already have an estimate of the weight of the flyer itself. I'm kind of over-designing this. I haven't really made a good estimate of the flyer. Basically, I started this 5 kilogram thing based on which load cells I could get easily and which ones seemed to be within the range of what I could design for easily using plastic parts like this. I expect the flyer to be a lot lighter than that. The flyer is mostly going to be the gimbal, the camera, Raspberry Pi, and some plastic parts, and a camera. But yeah, I think the next step is to watch this thing wind, which means I need to put some more pulleys on here and then just do this again. So let's ask the CAD what kind of bolt to use. Oh, actually, I feel like putting the optical encoder in next, but let's also ask the CAD what kind of bolt to use. So that would be over here. I need that to go to the end of the screw. Where is the end of the screw? This is a problem I keep having with this program, is that I have to like stop moving and then wait for all the hidden lines to load. Or is that not the problem I'm hitting right now? Is this a different problem? Oh. That's a different problem. How did that happen? I think somehow I cut a hole through the wrong bodies when I was modeling that. Well, let's try M3 by 8 maybe. Yeah, that's a bit of a mess, but I don't know that I care that much. So, optical encoder. Goes in there. Len says, I don't know if I could sleep with several of those running off and on all night. Yeah, I don't know. I'm not sure how noisy these are going to be. I'm actually really good at sleeping with noisy stuff going on, so I'm not super worried about it, but it is a concern. It will be such that I think these can be pretty far away from where I'm sleeping. Like, I think these can basically be at ground level, and I sleep in like a loft here. I need a different wrench. Lime green wrench will not save me now. This is the part that's probably most messed up by that little print error that happened this time. You can see the holes are kind of obscured by slightly messed up versions of themselves. I might need to actually ream that out a little bit with a tool of some sort. Yeah, hidden lines or secret lines? This project has been quite a learning experience for Fusion 360. I still have a lot of dislike for the way it does things in my heart, but I think I'm getting more used to it at least. And maybe that'll start to mellow out. Okay, these screw holes are not the clearest, but this'll do. Let's put that encoder back in. I think I have that lined up. What's going on? Just like digging up the surface of that metal without actually going into the hole. What is going on there? This is not the right size screw. I think it is. I think I was just bad at lining it up. Let's try that again. This feels like the wrong hole. I think this encoder slightly doesn't match my 3D model. Like the wire is coming out in a different place. Huh. Can I adjust that? So this has two different sets of holes that are 30 degrees apart, but the two sets have different diameters. So I think I was aiming for the other set. Like I think this CAD model might just have the two sets of holes backwards or something. Because if I center the wire by turning it a little bit, then the screw holes are completely not lined up. I think it'll still fit though, it just doesn't really work like I had planned it to work. So this will be another change for the CAD model. I think the easiest fix for this is to just rotate the mounting holes next time. Because right now the wire is coming out at kind of a weird place, but I think it'll still fit. It'll also be a good test to see if this capstan reliably turns. This is what I'm using for feedback for the motor speed control. I think this mounting, aside from being like 15 degrees off, is decent. Looks like there might be a bit of an off-centerness too. Maybe this CAD model for the encoder is just wrong. I mean, I did copy it from... I mean, like, I started the model before I had the actual piece based on something I found on, like, somebody else's eBay store who seemed to be selling the same part. And then I checked over it once I actually had the part, but I guess I missed some things. Vince is saying that the sound was the motor gearbox running and then coupling to the plastic surfaces. Yeah, I think so too. It sounded like the plastic was amplifying the motor noises, which might be a reason to try doing like a, I don't know, maybe like a flexible coupling around the motor. That could be an interesting thing, like give the motor a little bit of clearance and maybe 3D print like a Ninja Flex boot that fits around the motor. Oh yeah, and Ken is suggesting that I could try dampening, to try out damping the noises by exerting pressure on the drum as it turns. That would be interesting. That would tell me whether it was the drum or the enclosure. Okay, encoder's in. You can see the back. As you can see, that's not so elegant, but it turns out I need a lot less of a cutout here than I thought. So in fact, maybe I can avoid, because also the 3D model was a bit, it went overboard with how big the strain relief for this wire is. So I think given how this mostly escapes over that lip there, maybe all I do is, instead of having this entire cutout also, maybe I just chamfer the edge to give the wire a place to escape. Yeah, also this isn't going to be just like freewheeling all the time. It'll just be moving as the robot physically moves. So we'll see how much it's actually going to make a lot of noise. So that seems good. Let's see what kind of bolts go in these two. Two idlers go here. I think they both use the same. I think those are going to be another two M6x40s, but let's just double check in the CAD. Yeah, so these are the bolts we're after this time. These two, I think those are M3 or M6x40s. Let's just double check. $40mm. So that's kind of what we're aiming for. This is going to be a little annoying with the offset there. But let's deal with that. I need another couple of idlers. Here's one I printed earlier with the wrong kind of bolt in there. Let's get that out. 2 goes pretty chill. New project, make music with an internet-connected motor and sound box. Yes, that sounds about right too. Orange wrench. Orange, you glad I have the right wrench? Get her turtle. That's a good idea. This is very hard to hold the nut the way I attach this. Oh, do we have a working Ken icon? Did that change? There we go. Let's reset this while we still can. Okay. So this is supposed to have a little bump that matches this. I'm a little worried about how well this is going to do with the offset, but it seems potentially all right. Yeah, it's not so good. I don't have a good feeling about this. I don't think this is going to work. Oh, maybe. That's a good sign. Let's see if we can just keep going. That's about the right time to put a nut in the back. Why? So Ken is suggesting off-the-shelf pulleys. Why is that? I'm not sure how that solves a problem. Because these can be exactly the shape I want. That's all right. I mean, it's rubbing just a tiny bit, but I think that's because of my printing offset. Yeah, that could be better, but I think it's going to be enough to do a quick test at least. I think I should definitely increase the clearances around that. Oh yeah, here you can see the problem pretty clearly. So this whole thing is angled by a few degrees that way on account of the print error. So can I pull this a little? So it's rubbing a tiny bit because of that, but it'll be enough again for us to do a quick test to see if the rest of this works all right. But that is something to maybe accommodate for a little more, and to also just like have the print not mess up that particular way next time. Another little idler here. This one should be a lot simpler. That one seems to have plenty of clearance. Yeah, I do want to make sure that these holes are not quite so tight because it's easy for the bolts to sit a little crooked the way this is currently designed. was putting a nut in the back of this, and I think there's a tiny bit of support material clogging up the hole. There we go. Hold that nut in place while I tighten this. Yeah, I think to test this properly, I might need to install one of those pulleys on the ceiling and start having a weight I can lift. And it wouldn't be hard to get a pulley near the ceiling. Installing it on the ceiling is hard. But I have things I can lift it with currently. Got our idler there. Slightly crooked due to weird print, but I guess it'll do. I like Glenn's suggestion that Ken Keeter, while he's up late at night not sleeping because of things rotating, you can watch out for binding and shimmying on my rotating 2-co cam parts. I think the only piece left is the capstan, which I'm going to steal from this other encoder. Using one of these wrenches. Dark green wrench. This is the one that has the very odd set screw that comes in at an angle. Clearly, Mako MK says, clearly there needs to be a 2-co cam watching the 2-co cam. Yeah. And we call this engineering. I think that's the right distance there. Okay. For some reason, this is the contraption I designed. Let's see if we can run some cord through it, maybe. I think I might need to snap this into a vise so that it holds still. This is fine. So maybe get this so the camera can watch it wind. This is gonna fall over though if I don't try to center the center of gravity over the vise. Yeah, do I need a bigger vise? I don't know. The vacuum base sort of works with this anti-static surface. Alright. So make sure we can rotate without any cord. wheels are fine. So let's run some cord. Oh, Zach, did you bring this tea for me? Is this for me? Yeah. Thank you. Whoa. Tea. I have the other pan of ice base over there, but it's holding the gimbal at the moment. So this is all still spooled up. Maybe I need the other camera angle for winding this. So, if we're starting from the pulley on the ceiling, basically, it would go through there, then around this idler, and through there, above both of those, like that. So the encoder capstan seems to be rolling along nicely. Cool, so let's put this through here maybe. So this goes through a hole in the spool. This is really going to tell me whether this part works at all. Alright, so that goes through there, and then give myself a little more slack so I can tie a knot. And then just tie a knot in this end. Doesn't have to be any kind of good knot because this will keep itself tight. So that keeps it from going through there. Cool. So then I think my goal here is going to be to try to approximate keeping a steady tension on here and then just watch it wind and see what happens and try to go pretty slow. I'll start out with just a couple of volts. And I'm going to control it over here. I'm going to try to keep it under some tension. You can see all the idlers winding, except for the last one, which is sometimes stuck. As I mentioned, there was a printing error that caused the top of this to be offset just a little bit, so the bolt holding that wider idler is a little bit skewed, and so the whole thing is not amazingly straight. I'm also not doing a great job at keeping this under steady tension. This seems alright so far. I would turn up the speed, except I don't really have a free hand, so I'll try to drop this. And then seems to be winding alright so far. Oh, Sodium says as a quick fix for the wonky wider idler, would filing and or sanding it help? Yeah, probably. I could make the idler smaller. I could also maybe take this core piece to the drill press and give myself a straight M6 hole to use. I'm giving it really inconsistent tension right now because the cord is dangling around on the floor. So as you can see, the motor just stalled briefly because I was giving it too much to fight against. I've got to stop this because I'm out of cord. So that seems pretty good so far. I'm going to try maybe unwinding this and winding this a couple more times really quickly. I don't want to bore everyone with this, but it does seem useful to see how reliable this is. Peter says, does it seem to be bunching up on one end? To some extent, but I mean, it's like it did seem to be sitting on top of that knot, but I don't know if this is actually a problem. I think we're going to need to run it in and out a couple times to check. I might also need to run this with more cord. But yeah, this is certainly a question. If anyone thinks it would help to run this with more cord, I could probably get some out. Also might help to get one of the pulleys and just attach it over there somewhere so it's easier to hold this. Let's see if I can find one of those pulleys. Here's one. Something like this. Oh, a vertical rig. Yeah. Sanding the end. Yeah, several good suggestions. Let's try to see how I can set this up a little better. Peter says if I had two of them, I could run them back and forth several times automatically. That's a good idea too. Yeah, vertical rig. There's many vertical things here. A lot of them are being used to hold like lights and microphones. Maybe I can put a pulley. Yeah. Let's see what we can do here. Ken suggests using Tuco in a cat harness as a counterweight. I don't think he'd like that somehow. This will be vertical-ish. Sorry about the squeaking. It's like a little, it feels like a cassette player or something, with all these spools and wheels. Oh, Paul suggests try without going around the big idler to see if it still works. Yeah, I guess that's a good suggestion. We could just take that one out and go like that. I mean, I feel like it's almost certainly going to rub against the edge of the small idler if I do it that way, though. But we could try both. Let me see where I can put the other pulley. I think I'm just going to put the other pulley on my light stand and hope it doesn't pull the whole thing over. You know, I could go all the way to the ceiling with this. Excuse me, Tuco. Lowering a sandbag so I can grab onto it a little bit. Took. This one's not for you. Okay, let's try that. I need a small bit of paracord to attach this. You know, I could just run until the spool fills up. I have plenty of this paracord. Yeah, let's maybe use a longer section of this. Unspooling what I got. Almost unwound. There we go. So I'm going to use a little bit of this just to attach the pulley to... Or do I even have to? Actually, I don't even need that. Let me try to give you a better view of what I'm doing. So I've got that, and let's attach this for testing. Oops. Accidentally the cat cam menu. Oh, Took, don't eat the paracord. I should take that down a little more, maybe. Actually, I think I want the pulley under the sandbag, because if I take the sandbag off, then it gets much harder to manage the length of cord between that and the ceiling. So I think I will steal a little bit of this paracord for attaching the pulley slightly lower than the sandbag. Tuco, that's mine. Alright, so we've got a pulley on a length of paracord, which I'm going to attach below the sandbag. A lot of people ask me what these sandbags are for. It's mostly because if you have like a pulley and rigging attached without any weight on it, then it's going to get tangled and not move reliably. So it's like you usually need to keep some amount of tension in it for it to be easy to work with. So, got that looped around here. Now I'm going to feed a length of paracord in there and then raise that up a little. I don't want to put a huge amount of load on this because this clamp on the ceiling is not amazingly good and I don't want it to come crashing down. But this will be at least enough to do some experiments. Alright, so long thing of paracord. Through the pulley. And then back down to here. Wind it onto the machine. Tuco, don't eat the paracord, honey. This does need to be pointing at the pulley. On the bright side, this thing's pretty easy to wind with the cover off. Okay, so the bottom end of this is attached to the winch. I will raise that back up some amount of distance. All I want for now. So, just a small amount of air pulley. Not putting a huge amount of load on that. Let's just try winding this. Oh yeah, Ken is asking for a static load. Yeah, I think I might do that after winding some cord onto it. Because if I put a weight, I mean, like right now I can't wind a whole bunch of cord on it with a weight on it because I didn't put that super high up. I could bring that higher up to the ceiling, but I don't know if I quite want to do a test with an actual weight on it just yet. I think right now I just want to try to guide this into the pulley at a reasonably constant tension and just watch it wind for a bit. And then I'll try lowering something and raising it a bit and see if that ends up causing problems with the cord bunching up. This isn't quite aimed right. See if I can adjust that a little. I mean, that's better in some axes, worse in other axes. Lighting's a little better that way, though. This is also a little bit weird dynamically because the sandbag is swinging slightly. Anyway, let's see if we can run.
hand cam. You'll see there's some little loops going up here that I'm having to kind of straighten out, and that is a little uneven. This is definitely more uneven force than I would expect it to have, but let's see how bad it is. It does seem like the cord wobbles side to side around that bulge in the middle. Oh, yeah, the cord is not super orderly right now. Maybe it would be better to do a test with the pulley higher up toward the ceiling. Well, Ken is asking, I wonder how important evenness of take-up is in this design, or is to this design, though. Well, that's a good question, because, I mean, the way I was hoping to design this is that evenness doesn't really matter that much, and that I worry about metering the cord as it goes in and out, kind of on the capstan end. But the problem is if the cord can, like, slip under itself and get caught, then that's a huge problem. So that's part of what I'm watching out for. That noise is the pulley at the top rattling sometimes when it gets twisted, which is also something that is going to be, well, it'll be easier to avoid, I think, once this is more put together, but would make an annoying noise if it actually happened. I think this is enough. Let's try maybe taking this up and down a little bit, maybe. Mikey RM says, could always make a two-sided version, support for all the pins and pulleys on both sides. Yeah, I guess there, I mean, originally I was kind of discarding that idea because then, like, there's no way in, but if there were basically two core pieces and then a shell piece around there, that might do. Yeah, that's an option. Anyway, so just for a closer look at the winding, you can see it wasn't totally even, but might be even enough. Let's try, man, I don't necessarily want to cut this cord right now, but I think I might try just looping a weight into it somewhere. Which means untangling this slightly. There's a lot of, oh man, the cord is very twisted coming off of the spool. And this pulley has a way of twisting, it's just not very smooth at it. So if I help the pulley untwist, now it's doing much better. I think this pulley maybe does better with a rigid mounting above the joint, because I think the problem right now is I mounted the pulley with paracord, and so it's easier for the paracord to twist than for the pulley joint to actually twist. So I think, how much weight do I feel comfortable using? Let's try just attaching this little tin of solder spools temporarily to give it something a little bit heavier than me just pulling on it. Oh, I did that not completely wrong. Okay. So I have that attached. Oh man, getting this on camera on the desk is leading to this not being a really great situation with the, I don't know, I'd prefer to do this somewhere with less stuff around. I'm not going to send this super high up. I'm just going to run this a little bit, and I'm going to have to hold it to the desk too, I'm sure. If this was in a better position, I might try clamping it to the desk. Maybe that's still a good idea. Let's try clamping this to the desk. Does this work out? Let's do that on the other side of the knob for more leverage. More. That would work, except I'm also clamping the spool to the desk. This needs more up angle. Hey, Tuco, can I move you? There we go. Okay, so this is going to still be attached to some cord on the bottom, just because I didn't feel like cutting it. Is that just letting cord out? You have to go a lot slower to start with. Now at this low speed, the motor's stalling. pulley is twisted. I really need a more controlled situation to test this. This might be a good time to switch to the Gimbal project for the moment. So the motor is stalled again at 2 amps at 3 volts. Adding a little more voltage. I'm just killing the power to see what it's stuck on. I think I just need a little more power. I think this power supply is hitting its current limit, which is 2 amps. The pulley just needs to be a bit more off-axis to prevent twisting. Yeah, I mean, that's going to be a lot better once this is actually, all the pulleys are meeting in the middle. Now I'm trying to parse another comment here. This is from HLA. I'm sorry, I don't know how to pronounce her name. Who says, I think it would be better to have loops of the cord and just rolling them instead of winding on one end and unwinding. Yeah, I mean, that's a different design. The problem with that is that then the winch robots would need to be at the ceiling, or I would need to run another loop back up and would need even more pulleys. And it just seemed like a much simpler design to have a take-up reel. There's a huge design space for this, but I think having fewer cords going up and down is going to be easier, and the robot is not going to be very heavy. Like, this is probably heavier than the actual robot. This is like a bunch of metal, and the robot's all going to be plastic. Well, except for some little aluminum gimbal brackets. Also, there are going to be 4 of these holding the robot. Okay, so the pulley is not twisted. Let's see if we can get any upness out of this before we run out of current. Yeah. That seems fine. That was like 3 amps though. At 6 volts. So I might need a beefier power supply for this contraption. They're saying in chat that the forces of the robot being in the middle will be multiplied and will need strong motors. Yeah, that's why there's a strong motor in this. Right now the limitation is not the motor, it's my power supply. I was only giving it 6 volts and it's a 24 volt motor. Okay, let's go backwards. Takes a lot less power to go quickly, huh? Okay, I'm gonna try cranking this up to at least whatever this power supply will handle. Let's give it 12 volts. I think it's maybe operating a little more efficiently at those voltages. And 12 volts going down is dropping it pretty quickly. At this point, an H-bridge controller would be helpful. So maybe that would be the next thing to try. Because I do have an H-bridge controller. Maybe you'll just need to have the motor a bit lower. Not really sure what you're saying in chat, sorry. I mean, the motor is going to be pretty low to the ground.
Solder on a pulley. Yeah, I could totally just have my solder and all the other tools on pulleys that go up and down. Just need to make more winch pots. Oh man, it's like a robot for raising and lowering things. That's fun. I'm gonna get another wider shot of this maybe. So that's like 3 volts going down. And I'm gonna give it like 8 volts going up. Not bad. Mikey is asking if the fact that the motors can unwind with load faster than winding be an issue. Yeah, I don't think so, because basically the motors need to have a lot more capacity. You know, these motors, if I run them at full blast, are going to be way faster in either direction that I want. But the goal is that the motor is like is the output of a control system. So there's going to be a microcontroller on board here where the central robot will tell each joint, this is how fast the cord should be going at most. Maybe also this is a limit on how fast you can accelerate, and this is a limit on the forces that should be on the cord. And then it'll report back with current values. Kind of like a current limited or voltage limited power supply. This would be a motor that can be limited by kind of cord tension or motor acceleration or whatever. And then all 4 of these axes would be used in combination by that central controller over Ethernet to run the robot. And I'm really sorry I don't know how to pronounce your name. It's H-L-A-W-A. It looks like it's Polish, but I don't know any Polish. I'm sorry. And they're suggesting the cord might need to hang kind of at an angle instead of straight across. Well, yeah, definitely. I mean, there are going to be a range of cord angles depending on how high the robot is across the ground. You can imagine as the robot wants, as you command it to fly higher above the ground, you'll end up needing to put more tension in the system. So there could be limits on how much of that. I do have some pretty favorable geometry here since I can mount the pulleys significantly higher than I actually need the camera to be. So I don't know that the forces are going to actually be that severe in this particular installation. But for example here, if I wanted to fly the Tuco Flyer way up to the ceiling, the forces would be more significant. But just for some idea of what I'm dealing with, like, there's a lot of ceiling space, and I don't need the Flyer to fly that high. I can use a lot of that as space for the cords to have their angled geometry happen. So anyway, I think that might be enough of an experiment with this right now. I think maybe the next step here is obviously there are some small problems I can fix in CAD. I'll probably do that off camera since I've been doing a lot of CAD streams lately, and I think the CAD streams get a little old when I do too many of them, but if you like CAD or if you don't like CAD, feel free to leave me comments about that. But what I should probably do, besides fixing the easy little CAD problems, is to come up with an experiment rig that'll let me actually test this in a more real-world scenario and like spooling and unspooling a bunch and try to see how reliable it is. And for that, I think what I might do is attach a pulley somewhere pretty sturdy, maybe up at the ceiling like this, and then put a weight on it and just have an H-bridge driver spooling and unspooling and just like run that for a little while and see if it fails. Oh, I'm sorry, your name is Czech, not Polish. Yeah. If you could send like an audio link or something, we would all know how to say it. Okay, silent H, like Loax, is that right? I like to learn how to pronounce things correctly, but it is often does require a lot of different kinds of knowledge coming together. Hey, Tuco. So, let's maybe switch back to gimbal mode. For that, I need to lower this a little bit. Hey, Tuco, you want some attention? That is pretty fun. I think I'm going to enjoy having these robots that can lift things. Hey, Tuco, do you want to play? Are you looking for a break? Do you want to play, Tuco? I don't know what he wants right now. I'll leave that there in case he comes back. All right. And for this, I'm just gonna unhook my dummy load. See, it's an electronic dummy load. Oh, and I guess maybe what I should do is spool the rest of this back onto the big old thing of paracord. Oh, Tuco, please don't. Tuco does like this stuff. I have to be careful with this around him. Oh my, Tuco. It is tempting to mount this on a power drill, but I don't think I have the right kind of adapter. Oh. Oh, some good comments from chat. So there's a pronunciation key. Let's see if we can run this. Oh, web speech synthesis. And type this.
Hlavach.
Oh, okay. Hlavach. Thank you. It's always good to have that. And so then Paul says the gear sound seems to have dampened under load. Yeah, that does seem to be the case. I'm pleased with that. I'm still worried that once I put the enclosure half on, the one that I'm printing right now that actually also holds the spool, that's going to end up getting a lot of vibration, but that's something else I can change in the design later if I need to. This is going to be a little tricky because that keeps twisting itself. I can keep a little bit of tension on this, then unspool this. Whoa, that was a problem. Did anyone catch what that did? I started this without any tension on it, and it just sucked this right off the wider idler. I'm gonna have to start a little slower than that. So there was a little bit of a thing where that paracord was buried under another layer, and if I didn't have any tension on it, that top layer would have sucked it under again. It would have gotten really tangled. But if I unspool it with some tension, it seems to be doing a good job of unsticking itself. This is pretty nice and even. If I don't spool this at the same time, I'm going to have a huge mess, though. Oh, I just did the same mistake again. That was my fault. These spools are not designed to run with no tension. You have to have some tension to keep the cord in its spot.
Ken says, I think the cassette tape approach will be nice. What do you mean by that? Is this another vote for the having the spool? Oh, you mean like two of these spools testing each other? Oh yeah, maybe that is a good idea. I mean, that means I have to print another one of these. I was hoping to avoid printing multiple copies of something I don't know is actually a final version yet, but I guess I don't have to use the final version to test the final version. I can have different versions of this testing each other. Oh. I can kind of notice the noise when... So the uneven winding definitely contributes to some unevenness in the relationship between motor speed and chord speed. But since I have that encoder capstan, I don't think that matters that much. And now I'm feeling some other unevenness because the sandbag I have this mounted to is swinging a little bit when I pull it. Get a better view. Let me stop this to reposition the camera and maybe get a head start on the winding. Hey, Chica. There have been so many spools in this project. Spools of paracord, spools of 3D printer filament, printed spools, incorrectly printed spools, assembled printed spools. It's almost like this project is just a collection of one-dimensional objects. So maybe having totally even tension is not as important as I thought it might have been. Maybe it's just more like having a minimum amount of tension. Oh, Ken's asking about the elasticity of the paracord. I mean, the paracord certainly is elastic, and I'm actually kind of hoping that's a good thing. I mean, it makes absolute positioning harder if that's what you're into, but that's not really what I'm aiming for. And if I do want absolute positioning, I can use something like a lighthouse sensor for feedback. I think the bounciness is actually going to be kind of nice in that it'll dampen out vibrations and, just generally prevent like with metal, it's very easy for things to happen too quickly. And I think with this, it'll kind of even out some of the motion a little bit. Just act as a nice low-pass filter on everything. Yeah, Ken says, unless Tuco decides he wants to be part of the Tuco Flyer. Yeah, that's part of what the sensors are for. Like, I want to keep this away from damaging any humans or animals, so I think that the force sensors hopefully will help with that. Also having a, depth camera on the Flyer for sensing obstacles. This idler is definitely just rubbing, but it still seems to be working all right. I'm sure if I open that M6 holdup with the drill press, it would work a little bit better.
Just add wings to the robot and stabilize by flapping. Yeah. I mean, I could make it a quadcopter, but that sounds louder than the winch bots. It does help to use some quadcopter technology, though. The gimbal has been nice. With a little bit of customizing. This is almost at the end of the spool. So Mikey's asking, what if you leave the camera parked on one side of the room? Will that mean more stretch on one cord more than the others, with Ken's relative position in mind? Yeah, I mean, it will. I mean, the cords will have different amounts of stretch, but like you'll still be flying this thing. Like if you want to put it on that side of the room, you'll be like driving it until it's at the position you want, or an algorithm will be driving it until it's at the position the algorithm's headed for. So I think that it's not going to matter that much. You know, it means that the relationship between how much cord you're using and the position is complicated, but I don't think that particular thing is going to really matter. Okay, so that's totally unwound now. Uneventfully unwound. This just needs a knot undone, and then I can actually get the cord off. Ronnie asks, how well would a mouse sensor work on the paracord? Actually, that's a really popular question. A lot of people have asked that. And it might actually work all right. I think that the encoder might be more reliable than a mouse sensor, but the biggest problem with the mouse sensors so far has been kind of reluctant to design a system around them, given that it doesn't seem to really be possible to buy them unless you're just buying a mouse. And I don't really want to design this around a mouse unless I have to. For a while, Parallax had an optical mouse sensor kit, and I actually have one of those. But if I designed this around that, I mean, I wouldn't have enough for 4 robots, and it feels like a bad move to design something around a part that's already obsolete if you're planning on ever making more of those. So yeah, mouse sensor is an option. It's just right now those aren't as friendly to use as just a plain old optical encoder. Mikey says, I can picture this thing going full speed back and forth across the room with people trying to get it actually flying. Yeah, I could see that too. Might have to put some limits in. But yeah, I'm certainly interested to see how people use this, and I'm sure there'll be kind of a, like, I'll probably want to have some additional control over like maximum speeds, or like, don't be like stalking me all the time. This is for stalking my cat, not for stalking my house guests, you know, things like that. But I think it'll be something that we can easily add stuff to, improve the design, and make it easier for everyone to live with. Embed magnets into the paracord and a Hall effect sensor. Yeah, that would be some expensive paracord. Rory is suggesting, wouldn't Dyneema cord be better than paracord, not as elastic? I've never tried Dyneema cord. I have no idea what that is, and I've already got a spool of paracord, so I'll probably use the paracord unless it really doesn't work out, but I might check into what Dyneema is. I've never even heard of that. I mean, I was hoping that some amount of elastic would be good, but it's possible that paracord is more elastic than I want. Oh yeah, and Sodium is saying that the gimbal is also designed to be mounted on a drone or something, and they'd be surprised if it can't handle rocking. Yeah. Yeah, I think the gimbal is a big part of the reason why I'm not super worried about having a really stable positioning mechanism. Since with the gimbal stabilizing angles, there isn't really that much seasickness you can get by like focusing on a relatively far away target and then just moving a little bit. I think it'll probably be all right. There's certainly, you know, I don't want to count the chickens before they're in the basket or anything, but I'm feeling pretty good about this design so far. So yeah, there's our winch so far. Motor's barely even warm. Oh shit. Uh-oh. I just made a nice scar in my brand new anti-static mat. Well, thanks, motor. Sad. Oh well. So, well, there's that so far. I think we're going to put this away for the moment and swap back to Gimbal Town. Just for another look at what we've got. So the wire idler is a little bit crooked, so it's not really sitting right, but the rest of this seems to be working out pretty well. Oh, interesting. So Dyneema apparently is a cousin to Kevlar. Super thin, super strong. That's cool. Part of this was I kind of intentionally don't want it to be that strong because I don't want it to be that easy to hurt someone with, but yeah, I'll keep that in mind for sure. Oh yeah, Microhex points out there's a lot of mouse sensors on DigiKey, but all long since obsolete and they aren't made anymore, or you can't get ones. Yeah, and the sensors that are used in modern mice seem to be all like super trade secret-y things that people aren't actually selling unless you make deals with someone. So, and this piece is also something I want to test, because we should be able to just measure the load now. It just requires doing some wiring and, you know, probably just playing with an Arduino library for that part. Oh, those are the load cell. Okay, never mind. I had said earlier that I designed mounting holes for the load cell amp, but didn't actually print them, but I think I had a print failure. And so in the new print, I actually did get those in. So this is where the load cell amplifier goes. So that can just go in there probably with, I think I was going to use brass inserts. We could even put those in there, but I should probably save that for a different stream. So that'll have M3 screws, brass inserts. These wires will just solder onto, oh, actually it's this way. So the board goes like that. Those wires solder right onto there. And I think I need to actually, because this is a 4-wire sensor, I forget exactly how it wires up to the HX711, but we can figure that out. And then on the other side, we just have power and I2C. So this will keep the sensitive analog wires pretty short. So that's what we got so far. I'm going to put this aside and bring the gimbal over. Alright, Gimbal Town. Alright, it's a little messy here. Let's put a few of these hardware bins away. So we're getting back to trying to get this gimbal happier. Which sort of is a multi-part project. Part of this is just trying to reverse engineer the gimbal enough that we know how to talk to it and know how to set its parameters correctly. But then we have kind of this sub-project where in the process of trying to figure out the communication protocol, I just messed up the parameters in my modified gimbal somehow. This is the gimbal that's already set up to accept the camera, and this is like the one that I was about ready to fly, and we were going to fly to put on the robot, and we were trying to figure out how to control it using absolute angles over the serial port, using basically undocumented commands. And then found some undocumented commands to change parameters, but not after already messing up the parameters somehow. So that was where this was for a little while. We had this gimbal that's mechanically doing really nicely, but the software is just kind of whack so that when you turn it on, it just tries to break itself. Like the control loop parameters are completely wrong. So then, Mark WHI in chat sent this spare gimbal. So that's actually over here. And so this is the same model, but has not been messed up or modified in any way. We've still got the GoPro attached. And so on the last stream where we were working on this, let me restart this really quick. So on the last stream where we were working on this, we booted up this brand new gimbal and very carefully sucked out all of its parameters and tried to load those into the gimbal that had been having problems. And the result there was actually pretty interesting. It seemed like it was working in 2 axes. So the pitch axis here and the roll axis seemed like they had their mind back, but the yaw axis still just wanted to zoom over to one side. So one thing I'm wondering here is if there are multiple problems, if perhaps the parameter, because I mean, thinking back to how this originally started having issues, there was one point where I sent it just like a long malformed get command that was actually just full of a bunch of zeros. And as best we can tell, it might have caused some kind of unrelated bug, like maybe a buffer overflow in the firmware that caused it to mess up a bunch of the parameters. So after that point, we just turned it on and all the axes would just start banging against the sides. It was really unhappy. But before that, there was this other issue where it seemed like it had started to lose control of the yaw axis. And so actually, I wonder if that problem actually happened much earlier and might have been related to when I took apart the yaw axis to add the extra debug connectors. And maybe I might have subtly put it back together wrong. Not sure how I would have done that, but it's possible. And so anyway, with the parameters put back into the kind of unhappy gimbal from the nice gimbal, we've got it back to a point where the yaw axis is not happy, but the other 2 axes seem fine. So there are a lot of ways we could proceed. The first thing that had occurred to me was to try going back to the experiment where I was, in Jupyter notebooks, in like IPython basically, and trying to just manually adjust the parameters. But to do that with the yaw axis turned off, and then just to work on the other 2 axes. Yeah, the yaw was definitely drifting before the serious problem was happening, and I wasn't sure whether that was related to my kind of ham-fisted attempts to control the gimbal over serial or something else going wrong. But yeah, maybe something wrong with the magnetic sensor. Oh, and I'm just also behind on chat here. It looks like... So Robert has a question. Does the STM32 on the gimbal have hardware AES, and can I try a partial key overwrite attack? I think it has hardware AES. I'd have to check the datasheet to be sure. I mean, I can picture the... So just to offer a little more context for other people who aren't right there on the same page with Robert and I, the firmware for this gimbal is encrypted. And it would be useful to analyze the firmware to figure out what the protocol is like, at least insofar as we haven't already figured that out. But it would also maybe be useful to get default parameters out of it, since I assume the firmware image also has a set of default parameters that you can extract somehow. But, and then RetroDrunk has a related question. I wonder if reflashing the firmware may trigger some reset to default settings thing. We tried that. It doesn't seem to. But yeah, that was something that we thought might have helped, and it seems like no such luck. We found something that might be a partial reset where we write... So the way the settings are structured, it's 128 slots, each of which seems to hold a 16-bit signed or maybe unsigned integer. The last of those slots was a version number. We tried overwriting the version number with like 0 or FFFF, and it causes it to reinitialize some of the variables, but it doesn't seem to give it enough of a full reset there. Ken Keeter is asking if this is an open source firmware that they're repurposing. As far as we can tell, it isn't. This seems to be, like the company that makes this, Feiyutech, they make a bunch of gimbals. I think that this firmware is like actually pretty good and is their secret sauce, and that they're trying to protect it, and so that's probably what's going on. And they have a whole line of gimbals. They have some with built-in control sticks. It might have been possible to get some of the same protocol information by reversing the control. Like, I assume they might have had a separate microcontroller in the control stick that's speaking this protocol. Yeah, I mean, I think so. Piotr was looking at, yeah, so Piotr looked at the Alexmos protocol, and it's completely different from this. Yeah, and everything we've seen so far is pretty its own thing. I mean, they have their own Windows-based utilities that we were using to set the parameters early on. That was kind of the way in that we had some Windows utilities that did some very, very simple stuff over serial, and then started poking at that to see what else might be possible. And we found the Windows software doing something that looked like a parameter get and set, which led to where we are now. But the Windows software had very limited control of the parameters. It only ever did a get on one parameter, which was the tracking rate of the gimbal, like its yaw tracking speed. So my plan here was to go back and try to figure out what the parameters were with the yaw axis disabled, and to see if I can use that to make some progress. So first, just power on the Raspberry Pi and get this back on the network. Oh, interesting. Mako MK is saying there's another open source gimbal that uses a distributed design and serial links between per axis micros, but the protocol on that one seems different. It'd be interesting to look at their design though, because that seems like a pretty cool design, and if you're building a gimbal, that might be an interesting way to do it. I think they did it here to save on the wiring. There could be different ways. Oh, so Paul in chat says, I saw a discussion on the internet about a problem with the handheld version of the FY gimbal, where the yaw would oscillate back and forth, and the problem seemed to be fixable by correcting the position of the Hall effect magnet. That definitely seems like something I could have messed up when I was reassembling this after adding this serial wire debug connection. Okay, and then Mako MK is saying that Storm 32 is the name of that other open source gimbal design. Interesting. Yeah, well, let's get this experiment set back up, and it is tempting to see if I can fix this by opening the yaw axis up again and then putting it back together. And at some point, I am going to want to take off my debug connector. I kind of don't want to do that if I think it's still going to be useful, but I would like to fly this thing more than I would like to reverse engineer it, so I think right now, if I can get this gimbal just to the point where it's behaving, I've already got enough info from the reversing that I think we can do most of the controlling we need. So yeah, maybe it is actually worth opening this thing up and taking apart the yaw axis, taking off the debug wires, since I think I'm done with those. I don't really want to go super deep into the destructive STM32 reversing on this thing, since, I mean, now that I've got the second gimbal donated from Mark, I might have that as a hacking platform, but I think the goal of this is to make a cat robot, so I'd like to have some progress on that, really. Oh yeah, Piotr's also suggesting if there'd be an open source replacement firmware for that gimbal, that would be a win too. For sure, I mean, if there's an open source firmware that's close enough to be compatible with this design, then that might be a really nice project. I'm a little sad about this scar I left on my desk already. If you didn't catch what was happening, I had the vise positioned so that that wheel was rubbing up against my anti-static mat. It's okay, I'm sure it's the first of many. So I guess right now there's a crossroads. I could power it on and try powering it on without the yaw axis, or I could just open it up and like work on the axis right now. Oh yeah, Sodium says FY's design seemed like it also saved on PCB and manufacturing related cost because all the axes were almost exactly the same, definitely. Yeah, I think it's a really cool design. Ken says, wait, when you say cat robot, are you thinking like a cat cyborg or a cat that's also a robot? Yeah, well, I mean, in the broadest definition, I think Tuco is already a cyborg because many of you are already interacting with him over the internet. And I don't know, but that's a very, very broad definition of cyborg if you include like the bolts and the camera as part of Tuco. I'm kind of reticent to open this thing up and take off the debug connector, but I think I've already got all the stuff I care about. Like, I saved traces in the SIGROC project that I've got. If we go back there briefly. Let's go to this one. Yeah, so Tuco Flyer will be important soon, but the work that we're doing right now is just under scanlime / FY Gimbal on GitHub. So I've got this stuff in traces. FY Gimbal, settings app to internal bus, and PWM to internal bus. I think those are basically the reason we needed to do that internal soldering to get access to that bus. I can't think of anything else I need that for, so maybe I'll just open up that axis right now, take off that debug connector, and make sure that the magnet is in there correctly. Sodium is totally right. They're suggesting that Tuco is moving very slowly and kind of like settling out like pitch. Tuco, I should find some time lapses that I've done of Tuco. He just settles like a liquid when he's sleeping. It's really cute. Okay, so 12 volts turned off for now. And I'm on the computer right now. I do want the anti-static wrist strap. And the wrenches. Alright, well I don't think I have time for a super extended debugging session on this today, but I think at least I want to open up this axis and put it back together. And if I'm really lucky, maybe that fixes the axis and I turn it on and everything's happy. If not, maybe we go back to plan A.5 and try running it without that axis turned on and see if that can be made somewhat happy. Okay, so I'm unplugging this connector again to just take this whole thing off. Aw. Ken suggests if Tuco Flyer has its own protocol for communicating with the Gimbal robots, could it please be called Cat Bus? Yeah, maybe. I mean, it will need a protocol for talking to the individual Winch robots, and that could definitely be a Cat Bus or a differential whisker protocol, as Piotr suggests. It is quite possible I assembled this axis somehow subtly incorrectly. Ooh, I think I'm going to need the microscope. Maybe I need the Raspberry Pi to not be in the way here. And I like differential whisker protocol. I think Tuco already knows how to speak that. He also has, I think it's kind of like SMTP, but he implements it entirely via rubbing his face on things. Yeah, sharp claws for hacker resistance. Yeah, I can second that. Tooth-based denial of service attacks. Yeah, I do have to be careful with the wiring for that exact reason. Alright, so here's our gimbal. All these little limp axes sitting around. And right now we just want to open this top one. To do that, I have to take this board off. I think it's easier if I take that board off. I don't know if it's strictly necessary. Which tiny wrench do I use? I think this is a job for the white wrench. Cognitive cat bus. Oh man. Ooh, this is not a wrench that I have right here. Where is this wrench? There we go. I don't know what size this is. It's between 1.5 and 2 millimeters. I'm now reconsidering whether I actually want to take this apart, or this particular screw, I mean. Yeah, let's leave this screw in. I think I might not need to take this board off now that I think about it. And this little white wire is connected directly between the inside of the gimbal and this board, so I can't take the board off entirely anymore. So these 3 screws take this cover off of the motor assembly. I think that's the next step. And I unplug the motor. I really don't like, I mean, I'm kind of tired of taking these gimbals apart. It was fun the first time, but they're really fiddly. Oh. The YouTube chat has been dubbed the uncool kids table, apparently. Just in case anyone in the Gitter chat needed to know where the uncool kids table was. I think the YouTube chat is fine. It's just got some... Like, I think a lot of us like Gitter because it's easy to keep in touch even between streams, and it doesn't have some of the same kind of like filtering problems with YouTube. Like, it was kind of annoying not being able to post links, for example. But I still try to keep an eye on the YouTube chat. Alright, so there's the motor again. I wonder how hard it would be for that magnet to get out of place. So there's the motor spinning. You can see that the connector and that outer ring move together, and that's the motor's stator. But then there's a little ring in the middle, and that's the actual magnet for the position encoder. So that stays put. Yeah, YouTube zapping the chat history once the stream finishes, as Sodium said. That wasn't so fun. That made it hard to keep in touch. We would often have... I mean, some of it is about keeping in touch between the streams, but some of it is just, it's kind of nice to have a record of what goes on when we're like dealing with something complicated. It's kind of nice to be able to search back on what we've already been through. I think I just put my finger on the lens and I was like, oh no, I need a lens cleaning cloth, but I think that can wait. And I think the next step is to take this cover off. I kind of wonder if I, either by adding or moving wires, cause something to get in the way of the magnetic sensor. So it was acting a little bit like the magnetic sensor on this axis is just confused. Because I mean, it's so suspicious. Like the other axes just behave fine when I loaded the new settings in here, but this axis is still mad at me. But I think this will be a little easier to debug if I get the debug connectors or wires out of here. Alright, maybe the next aftershave is getting this under the microscope. Do we have microscope today? Hello, microscope. Are we having a lack of microscope video here? Oh. There's like a dangling HDMI cable down here. That better? Oh. Oh, microscope. Wow, apparently there are people in the Tuco Flyer Twitch channel. That's interesting. Oh, I thought I had everything working, but apparently there are always more HDMI problems to debug. If I reset this microcontroller or this microscope a couple times, maybe it'll be working. Oh, there's something weird going on with the splitter on the microscope HDMI. I power it up and then it loses the signal immediately. Oh, is that it coming back? I think that is. Yay. I just needed to reboot it enough. Oh man, apparently we've got... Okay, I've got a bunch to catch up on. Apparently there are people being annoying in the Twitch channel that we might need to take a look at. And then there's... Anara JB is asking, is it a black magic capture card being annoying? No, why would you ask that? No, I mean, I have a physical monitor here that wasn't showing it either. It was just an HDMI problem.
there's Tuco. I don't see anybody in the chat room right now, but it doesn't show chat history. I don't know, we'll keep that handy. Okay, microscope. I think the way I had to do this last time was to put the gimbal in a vise at just the right angle. I think I'm going to have to do that again. Have I mentioned how much I don't like working on these gimbals when they're partially assembled? I'm just going to clamp this by the LiDAR sensor. Very gently, of course. Okay. There are two of the wires I'm taking out. In there. Get the soldering iron ready. I think I'm mostly surprised that anyone was in the Tuco Flyer Twitch chat, because I haven't really been advertising that super much, but yeah, I'm sure it'll be interesting for people to stumble across that and be like, why is there just this random tripod pointed at something random? But once we actually have the chat commands, I'm sure there'll be some kind of like overlay indicating what the status is, and like, here's how you can control it right now. So this is going to be just a little awkward, but hopefully fast. These are the wires that we had soldered to the internal serial bus, where this micro is communicating with the next one.
just like new. And then the next spot was up here in the corner. That is serial wire debug, which is kind of useful. You can use it to read SRAM, and we can kind of use it to write SRAM, although after the debugger attaches, it seems like the processor isn't allowed to take any more steps. So there isn't an obvious way to use it to extract firmware, but it might be possible. It's just not really where I want to go right now. Oh, Sodium is like, maybe you can convince Twitch to add a cat game. Yeah, I haven't really been spending a whole lot of, or paying a whole lot of attention to the game categorizations on Twitch, but I went through there a little bit recently and I found out that I realized there was an IRL category, so that's what I have him set to right now. This one's the ground plane, but it isn't even that bad because this board's pretty small. Okay, well that's my connector gone. Let's just give this like another touch. That seems fine. Now it's assemble this and look really carefully for problems as I do so. Oh, Mikey is asking, were there plans to put a bolt launcher on the Flyer, or is that another platform idea? That's still kind of an open question. Oh, interesting. Mako MK says you should be able to write an execute code from SRAM, but it shouldn't be able to access Flash IRC. Yeah, I guess what I didn't try was setting the program counter to an address in SRAM and then single stepping. What I was getting was single step, just didn't seem to have any effect, but that might have just been because the program counter was in Flash. Apparently the IRL category is for tabletop games mostly. Well, I don't know where else to put it. 2Code can be a tabletop game, right? And then, yeah, back to Mikey's question about the bolt launcher. So I haven't really done hardly any CAD for the actual Flyer part yet. I imagine that's going to be kind of simple, but it probably also depends on how well the... so I have a plan to put a depth camera, like not a Kinect, but something similar, like the Asus XGen is the one that I have, on the Flyer, and use that to sense obstacles so that when people are flying it around on the internet, they don't like bump it into people and stuff that's on the table. And that's going to be one of the bigger open questions in the Flyer design, is like how to structure things so that that camera gets a good view and to keep the center of gravity relatively central. So before doing much of the Flyer CAD, I wanted to do some experiments with that Asus camera and a Raspberry Pi and see how well that works. But I still assume that whatever I do with the Flyer design, I'll want to have some like expansion connectors. Basically just leave some bolt patterns open so I can add stuff later pretty easily. I guess Robert got interested in testing out this line of inquiry on their own STM32 board, and they ended up trying to detach the debugger during, I assume this was with flash protection enabled, and it bricked the chip. That doesn't sound very good. Let's see. Just want to make sure I didn't mess up anything with like an errant solder blob or anything on here. It's the wire connector with a little bit of my own glue. That cut yellow wire is what used to be composite video, and I ended up removing it and using the extra space for a coax. And then later ended up adding another wire for my LiDAR trigger, which I could have just used that one for. So the white wire is the LiDAR trigger / result, and the black wire is a coax for the video signal. Okay, I'm going to take this out of the vise. Let's go back to the regular camera, maybe. Or maybe I'll just hold this under the microscope. I'm still looking for problems at this point. I think the most likely problem is the magnet being misaligned or some stuff being stuck in front of the magnet. This thing that I'm struggling to get in focus right now is the magnetic encoder. Oh, there are just so many pieces. Okay, so that chip down there, which is still not in focus, that's the encoder. So it is centered right under the spinning magnet. Oh, the spinning magnet is also not really in focus. Maybe the microscope has served its usefulness here. Oh, so Daniel is asking in chat if I can point to the Hall sensor really quick. Yeah, sure, we can take a closer look at that. So it's actually like, it's not just a Hall sensor, it's like an 8-pin SOIC that's like an all-in-one angle sensor, basically. And I think we had the part number handy on an earlier stream, but let's just, whoops, if I can hold the microscope and get this under there. Yeah, I remember not knowing what this was immediately, and then, oh wait, so there are two 8-pin chips here. I think that one in the back is just an op-amp, but this one in the middle, which is mounted, it's a little hard to see under the microscope, but this one is like right in the center of the case under the motor. So I think it's pretty clear that this one is the encoder. I haven't seen a data sheet for this one yet, but 12B1000, I think, looks like the relevant number. Let's see if we can find that really quick on Google. Oh, AMS parts. Is that what we're looking for? That model, that sounds familiar. Wasn't sure off the top of my head what this was, but yeah, 12B1000. Can we find that? I don't think this is the right number. I wonder if a little bit of liquid would help us see this a little better. Let's put a drop of alcohol on top of it. Come on, alcohol. There we go. I don't know, it looks like O12B1000 RSU or DSU or something. I think we honestly got a much better shot of this earlier, but I don't have that video right on the tip of my fingers at the moment. But yeah, that should be the magnetic encoder chip we're looking for. Alright, let's try to put this back together. I think the next step might be this little collar. Let's go back to the big camera. So the glue that's holding the magnet in is flaking off a little bit, but it seems like the magnet wouldn't have moved. I wonder how much it matters for the wires to be out of the way. I also wonder if it could have been a bad connection with the motor. It seems unlikely. There's like a little bit of glue residue on the motor pins. So that cover goes back on. These two tiny screws. Oh, the machining on these parts is so nice. I wonder how easy it is to just have the magnet get miscalibrated by changing its amount of magnetism. So that cover is attached. I don't know what else to do other than just carefully put this back on and try it out. It's a little hard for me to show you exactly what I'm seeing in here. The wires bunch up to some extent around where the magnet is, but that's how this worked before. Like, that isn't something I've changed in how this is designed. Ooh, do we have a part number? TLE 5012B. Ooh, that sounds good. Let's take a look at that in a sec. Thank you. So that's the joint assembled. It just needs 3 long screws. Maybe the huge metal BNC connector on the outside deforming the field. That's a good question. I wonder if that would be worth moving. The rest of this is like copper and aluminum, but yeah, this could have some steel in it maybe. That would be interesting if part of the root cause here was cannot operate with BNC connector too close, or the yaw axis will not measure itself correctly. I think Robert is confusing the stream chat with the KiCad bug report form. I'm pretty sure that lives elsewhere. I mean, as much as I like KiCad, I definitely encourage people to use it and to report bugs if they find them. Alright, those are snug. Gimbal assembled yet again. Doing its thing. Alright, let's try this out with this connector mounted slightly elsewhere. This microscope seems to be pretty picky about its HDMI for some reason. Like, I don't know what that was. The root cause of that was just I have a little splitter under the desk that sends the microscope video to the monitor and the rack where it streams. And it had just come loose because I was moving some cables around. But then upon plugging it back in, I felt like I just had to keep resetting stuff until it worked. And that's a problem I've had with this microscope before, so I think it might just be a firmware weirdness related to the HDMI output. Like, some devices try to be smart and like not enable outputs unless they're being used, or maybe they go into a different mode when the output's connected. So I think it was something related to that. And the microscope and the splitter kind of disagreeing about whether the output was being used. Alright, BNC connector safely way over there. This metal is all out in the edges too. So I think I just want to try turning this on with 12 volts with the Raspberry Pi powered off. The usual. See if the gimbal is happy or if it's trying to destroy its yaw axis again. And I think this might be one of the last tests I have time for in today's stream. Let's see how it goes. No, Mikey's jinxing it, saying fizzle pop smoke already. That's not the right thing. I mean, sometimes Sparky the Blue Smoke Monster shows up, but I don't think we're gonna see that this time. Oh yeah, every time I delicately move it around with that massive SMA connector. Yeah, this coax is 0.81 millimeter diameter, I think. Yeah. Ooh, can I get the power supply in the frame too? That would be kind of nice. That's a better shot than I usually get of this thing. Alright, that power's off. This power supply does not have an output on-off button, although it might have a new power supply coming soon, which could be awesome. Alright, I'm gonna still hold this just in case, very gently. So, 12 volts. It is gently trying to slam against the yaw. You know, that does certainly seem like it's trying to home to a position 180 degrees from where it's supposed to be. I don't know if you saw what it was trying to do, but it looked like it was powering up and then gently trying to swing this way and then hitting the end stop. Almost like that magnet was just backwards. I don't know how that would have happened, though. Maybe this means it's time to try powering it on without the yaw axis. Maybe we've reached that point in the afternoon. Could I rotate the magnet ring? I think I could, but it would require ungluing it a little bit. I'm really sure the hardware is put back together at this point correctly, because there isn't an opportunity for me to put that together incorrectly. Like, that part only goes together one way. I mean, unless there's something I'm missing. I think that one, because there are some other places where you can put it together wrong, but this particular thing that's been misbehaving started around when I took apart the yaw axis, and the yaw axis, I don't think it goes together any other way. Let's gingerly mount this over here. maybe the calibration. So I guess we were also thinking that there might be some per device factory calibration, and I wonder if that includes the position of all the magnets. Because I can imagine if you were putting this together at the factory, I don't know if you would have a jig to line up all the magnets exactly right, or if you would just calibrate it in software afterwards. But it seems like whatever's going on is only affecting the yaw axis, which is strange. Mako MK is saying, I mean, it might be worth comparing the parameters you loaded with the best ones you got from that gimbal. I'm not quite sure what you mean by that. And then it looks like Sodium might have found someone else experiencing a similar problem. Let's take a look at that. I think we want this screen. Yeah, so this comment about the magnet, like the magnet could totally be put in and upside down. It's just that it's glued in, and I haven't unglued it since this was working. So I know that that isn't the problem, unless it's just different between gimbals and they've compensated for it in the settings. Yeah, I mean, this seems very likely, this comment that the magnet rotation might just be random. I think that's quite likely.
That freaking Bose thing is, it was correct. On this.
Oh
I'm
yeah,
just gonna send it back if that happens.
that looks
Anyways,
similar.
We're gonna fix this today. If yours is doing any
Reset to
operation
factory
of
settings.
this, let's fix it. You need the gimbal update software. You have to have.
Oh yeah, so I guess we have not tried updating the firmware since redoing the settings with the ones from the non-crashed gimbal. We could try that pretty easily. That would just require hooking this back up to the VM where we have the Windows app, but I can do that. Let's do that. I think we want the other computer for this. Oh, did I miss the important part of that video? I was trying not to play the whole thing because I didn't want to, like, steal their video. But it looks like there's settings, and then this looks like the same firmware update app that we've been using. Yeah, well, I mean, if somebody knows if this is just a firmware update or something else, then let me know. I don't want to like play this video while I'm streaming because that seems pretty plagiaristic, but you put the gimbal down on the table.
For that freaking Bose. So I'm gonna set it. It stopped. Okay. I'm gonna set it down, plug it. So we just got this. Let's take our batteries, put it back in, and let's check it. Doesn't feel like there's any restrictions. So I'm gonna set it down, not doing anything fancy. I'm gonna click the button on the bottom. I'm just gonna watch it for a second. Oh shit, it's freaking out. But it stopped. Okay. Okay.
So am I missing something, or is this just that on
Yeah,
the
just
first boot it
calibrate it.
recalibrates?
Look at that. Okay. It's working.
I wonder if this is the same effect as when I'm using the firmware. So in
If it's
the
not freaking
Python
out
tools I've been
anymore-
putting together, I can just like blow away the version number at the end of its parameter block, and I think it might be doing the same reset in this case.
No, so I don't have a button on this gimbal. I think that was specific to something in the controller there. I mean, that button might be related to the mode input, but that's wired differently on here. There's like an analog circuit on that input that's expecting a PWM signal. That's interesting. I'm not gonna like watch that whole video on here because I don't want to like plagiarize that dude's video, but feel free to watch it on your own if you'd like to. Also, I think what I'm getting from this is that that might be a procedure to cause the little settings database, which is versioned, to go through like a full update cycle from a baseline set of parameters. Yeah. Let's at least hook this back up to the serial port. We can try just doing a firmware. Maybe what I will try is loading 2 different versions of the firmware on there. I don't know. I think I'd rather just try using my settings tool to change the version to FF or something and see if it recovers that way. In that case, I think our next step is Raspberry Pi, not the Windows VM. Oh no. What's going on there? Downgrade and upgrade, yeah. Yeah, so I think I get what that procedure is doing. I think I might have a shortcut, but if the shortcut doesn't work, then we can try doing the firmware update. But first, I need to get my Mac back to being useful, I think. What is going on here? I clearly left something running. But what? Maybe it was VLC. I don't know. That's still not responding. Unscheduled technical difficulties. Maybe I'm using PuTTY from the Windows machine. Can I at least reboot you? All right. Can't quite reach the button. There's a USB cable, which is not long enough. I think pulling the Mac out enough to get access to the power button dislodges that. That is such a mess. better? There is a keyboard connected. There should be. There we go. Yeah, no, I got that. I don't know why something I changed in my video pipeline means that this switcher seems to like defaulting to 720p, but it does work with 1080p. I don't know what's up with that. Anyway, I've got a computer again, yay. Oh, Mikkel's asking how I made the background. This is a photo. This is a milled circuit board with a scanlime in it. I dripped black wax on it and then hit it with a heat gun until it got bubbly and then solidified. So this was actually cold when I took the picture, but you can see the effects of it being hot. Let's see if the Raspberry Pi's booted. Oh. Did I not ever plug power into the Raspberry? How did that happen? Let's get us some of that too. Oh, yeah. Yeah, it's an interesting effect though. Like, it's kind of hard to tell what that is. But yeah, that was some of, it's like black sealing wax, like for sealing things. Sealing envelopes, not the sealing. Okay, back to this point. So we've got our FY gimbal. So the thing that we did so far, which seems to mostly have worked, was this dangerously splat parameters. This uses a parameter set from the good gimbal that Mark sent me. So maybe what I'll do is run this again, but change this version to either 0 or FFFF. And then try running this again, see if that helps. As a first test, there's probably more things we could try, but this seems like something to try first. So, I still have the Raspberry serial port connected. 12-volt power is off. If I run this program, it'll just sit there waiting for the gimbal to connect for I think a total of 10 seconds. Once it connects, it'll tell us, and then it'll do the settings. So we want to run this and then shortly after plug in the power. Or, well, we do that after changing the version here. What do we try first? So 1.15 is the firmware version that we have installed. So if it sees 1.15, it won't do anything. You would expect that if it sees like 1.14, it would do some kind of upgrade procedure for a 1.14 version settings. You also might expect that if this is like FFFF, then it might think, oh, this is erased, load some defaults. So the question is, what do we do to get it to reset the yaw axis? Or at least like reset the encoder centers, or whatever it's actually trying to do. Oh, you know, the other axes probably get reset each time it starts up using the accelerometer. And so this is probably the only one where it needs to store a calibration. So if we knew which one of these was the center, we might even be able to just edit it manually. But it seems like going through the upgrade process might be a good thing to do. What if we set this to a really low number?
Well, I'm curious what happens if we set this to 100, so if it was like for firmware version 100. This might be a terrible idea, but let's see what happens. This program is going to live up to its name. It's setting the parameters, and it saved them. So now, without this program running, I can turn this on and see what the effects are. I'm going to hold it. This seems the same as before. It looked like what the person in the video had found was some way for it to like slam against both sides and then calibrate itself. Oh, and then MakeOMK is suggesting comparing the parameters between now and before. Yeah, I mean, part of, like, we've been comparing the parameters a few different times, and part of the issue is that there are actually usually a lot of differences because these aren't just parameters. I think this is a mix of parameters and internal state and sensor readings. So just doing diffs, like, we've done a little bit of that, but the differences aren't totally obvious, so I need to make a slightly better diffing tool before I think that's going to give a lot of information. I just want to try this again, but change that version. I'm going to try 0 and all ones. Let's try all ones first. This is a signed number, so that's actually -1. Okay. Same experiment. No. That didn't seem to have any effect. Let's try 0 and then maybe a different line of inquiry. I still think it might be useful to try powering this on without the yaw axis so we can experiment with the other parameters. Or even, I wonder if we can just read the parameters without powering on any of the motors to get an idea of where the sensors are. And Paul is adding, the first time you boot after changing the version, you need to hold the gimbal so it can't move. The next time you boot, it's okay. I don't know if holding it so it can't move is what you want. I mean, yeah, I'll try rebooting it again just in case, but what I was expecting to see was it to go through a sequence where it tests the entire range of that axis, and that wasn't what I was seeing. It wasn't slamming against both sides. It was repeatedly slamming against one side, which I don't think is what I want. So, wait, did we try 0 yet? I think we need to try 0. Okay, so we saved 0. Now, powering it on the first time after saving 0. And I'm going to hold it. It's still trying to swing. It's not settling down. Like, this is not decreasing in amplitude, it's just swinging. So let me try that again. Same thing. Yeah, I don't think that's it. Mikkel says, what happens if you just let it do its thing? Will it break itself? Well, yeah, I mean, it's just repeatedly banging against the hard stop. It isn't changing anything, like it isn't getting less intense, it isn't trying to find both hard stops. Like, I have no reason to believe that this is going to end well if I just let it continue to bang. So let's not do that. Yeah, I think the next step is probably to try to figure out which settings are related to the encoder center position and to just modify those. It would be nice for this utility to have a way of reading back what the parameters are, though, and diffing them. I do think that would be helpful. I'm also just getting a little low on time for this and might need to wrap this up soon, but I'll have more time tomorrow to work on this. Yeah, I mean, I think it might be nice to try turning it on. There might be some of this might be very meta, like, see this one that's 0, 1, and 2? I wonder if this is actually the ID for each axis gets programmed in the same setting space. Like, if you got these set wrong, like, how would you change those? Because that, I don't know, that's probably something different, but. It would also be useful to just get a live dump of these parameters as it's running. Basically, there are a handful of tools that would be helpful to have to get the next step done. I just feel the urge to go in several different directions simultaneously, so I need to figure out which one of those is actually most useful right now. So there's a tool to just continuously pull down the parameters and diff them. That could be interesting. There could be a tool, kind of like my original plan for the stream, which would be to let you turn on and off individual axes and mess with the parameters on just those, axes. And the only reason I have to believe that I can do that is that the actual power on sequence goes out to each axis individually, so I'm thinking I just don't send that to the yaw axis. Yeah, I really, like, I definitely need to just start listing out, like, start coming up with, you know, what do each of these slots actually mean. I also kind of wonder if this is version related. The 0 and 2 is one of those that seemed to reset itself to the correct value somehow, says Mako MK. Yeah, and then there are only a few numbers that seem. Yeah, so there are a lot of different ways to go here. I think first I need to wrap up the stream because I'm about out of time for this today. But I think when I come back to this, tomorrow, I think the next thing to do is to just try to figure out which of these relate to the magnetic encoder. But the thing is, like, figuring out which of these is actually the encoder coming back isn't as useful as figuring out which of these is the center position. Both of those probably need to happen. I can imagine just having a tool that repeatedly queries these and then diffs them and tells me when things are different, and that might be useful for finding the sensors. But I don't think I have time to quite dive into that today. It would be a relatively quick program to write, but I think I need to be wrapping this up right now and not opening additional cans of worms. But yeah. I'm pretty sure at this point that the yaw axis is not assembled incorrectly. I think my favorite theory for that is that the magnet position is just kind of randomized during factory assembly, and then they have calibration at the factory that's per device. And obviously there's some way to enter the calibration, like that procedure from that video that we didn't really watch, or something related to changing, you know, the version number stored in these parameters. Maybe there's just a command to do it that we can send.
And Whisperfist is asking if I might stream tomorrow at a similar time. I don't know. I usually stream stuff when it's ready. Today, like, my schedule for the past week has been a little bit weird because I've been helping a friend move out, and so I've been kind of working with him and doing stuff outside of the house, and I've been spending a lot of my time here just doing CAD stuff. But that'll be different next week, and next week I'll be kind of back on a normal schedule. So, and then the question is, well, what's normal? So, yeah, I usually try to stream kind of for me in the afternoon and then kind of go as long as I can, but I also kind of try to mix it up. So if this time slot is good for you, let me know. If it sucks, let me know, and I'll try to take those into account. But I also just try to mix it up a bit so that people from various parts of the world have a chance to tune in live if they want to. So, yeah, and then we've already got some dibs on the numbers here. Oh, I'm sorry. I'm already forgetting how to pronounce your name, which I know I have the thing on the other screen, which I could be using to. Let me go back to this and get a reminder. Oh, this mouse is really warm. It was in the sun. Oh, I feel terrible. I already closed the window with the pronunciation key and then I forgot about it. It was inlined up here, wasn't it? Here we go.
Hlavac.
Ah, okay. Yes. Right. Thank you. Yes, so yes, Hlavac was already putting in some dibs on which numbers might be it, and yeah, this seems likely. 'Cause there are not a lot of numbers that seem like just positions in the middle of a 16-bit space. A lot of these seem like numbers that somebody would have chosen to be a round value. What I'm expecting to see here is that some of them are current status of the sensors, some of them are control loop gains, some of them might be signed gains, so they also indicate like what direction something is mounted in. Some of them are clearly version numbers. I wonder if some of these might be sizes. I'm imagining that these numbers that are really round numbers, they're not like binary sizes, but probably like fixed point numbers. So my guess with something like this might be that maybe this is a 1, but multiplied by 4096. Why did my mouse just stop working? Just having technical problems today. Actually, maybe this computer is having issues. Maybe that was just a coincidence, I don't know. Thought I was having computer problems again. Anyway, I think it's about time to wrap this up, and I will see folks tomorrow. I think this gimbal will have some interesting secrets for us to discover still, and if we're lucky, we can even use this just to point the camera at the cat, which is actually what I really like to do with this. Well, I hope that was interesting. I think we're making some good progress on this cat camera. I'm certainly looking forward to driving this thing around with the combination of an Xbox controller and Twitch. Well, nice to hear some feedback about the stream timing. Like I said, the timing often ends up being pretty random, but I try to take what people like into account and, you know, have streams that everyone who wants to watch can watch. So have another moment of full screen Tuco here. Just for a reminder, I've been starting to stream this Tuco camera, even though it's not especially mobile yet. If you go to twitch.tv/TucoFlyer, you'll see my work in progress stream. But
it is not yet interactive unless you like poke me and tell me to pet the cat. Then that's about as interactive as it gets. Pat, pat, pat. Yep. Oh, and thanks for the link to Go Flyer Sodium. Well, thanks for tuning in, everyone. I will see you next time, probably tomorrow afternoon. See you later. Oh, and just to answer Whisperfist's question in chat really quickly, if they're still there, they wanted to know how to say my name. It's Micah, although I'm not usually super picky about it. Some people call me Becca at coffee shops, and so I usually answer to that. And then for a while I was going by Beth, because my middle name's Elizabeth. But yeah, Micah's all right. I'll see you folks later.